So far, we have learned 4 different ways to solve quadratic equations. The first thing we learned was solve by factoring, and then square root method, completing the square, and the quadratic formula. So we're just going to review the steps for each type of factoring, and also we're going to talk about how you know which type of quadratic equation will work for each method. Starting with solve by factoring. Solving by factoring will not work for every quadratic equation, because if you remember, there are times that we cannot factor a quadratic expression. So similarly, there will be times that you can't factor if you're working with an equation. So it will only work with those quadratics that factor. The steps to solve by factoring are that you have to get your equation equal to 0, and you want it also to be in standard form. Remember that standard form, your x squared term will go first, and then your x term, and then your constant term, and it will equal 0. So this is what it should look like. The A, B, and C will be numbers, not letters. Then you're going to factor. And factoring includes all of those steps that we followed before. So get a greatest common factor, factor that out in front, and then look at how many terms you have. Remember that if there are 2 terms, that's going to be the 4 formulas we've used. If there are 3 terms, you're going to guess and check. If there are 4 terms, you're going to factor by grouping. And then after you've factored, you're going to use the zero product property. The zero product property, remember, says that if you have things that are multiplied by each other and the result equals 0, that you can set each one equal to 0. So basically, we use the zero property means that we set each factor that contains a variable equal to 0 and solve. The second method that we used to solve quadratic equations was the square root method. Now the square root method only works if there is a squared thing. So for example, it could have an x squared in it, so it could have ax squared plus c equals 0, or it could have a parenthesis, so it could have like an a and then a bx plus c parenthesis squared equals d, but it has to have some chunk that is squared. It could not have in the form ax squared plus bx plus c equals 0. Okay, that will not work for the square root method. The steps for solving by the square root method were to isolate the squared thing, after that was isolated, we were going to take the square root of both sides of the equation, and we wanted to remember to use the plus minus. That's very important, don't forget that. And then you had to solve for x. The third method that we studied was completing the square. Now, completing the square will always work. This will work on any quadratic equation. If you remember the equations that we started out with, they were a lot simpler than the equations we ended up working with. That's because it sometimes gets messy when you have to deal with fractions. So my best advice is that it's easiest, if you have to use completing the square, if you have to pick a special type to use with completing the square, it's easiest to use if A is equal to 1 and B is an even number. Keep in mind that we're working with ax squared plus bx plus c equals 0. So it's going to be easiest to complete the square if A, your leading coefficient, is 1, and B, your coefficient on the x term, is an even number. So here were the steps that we used. The first thing we needed to do was get all the variable terms on one side. And all constant terms. Constant terms, remember, are terms with no variables on the other side. Then we wanted to check to see, is A equal to 1? If A is 1, then you can skip the next step. If A is not 1, you need to divide each term by A. This is why it's easiest if A is 1, because if we're not having to divide by anything, we're not going to create any fractions. The next step is to find B divided by 2. Now, B divided by 2 is what we're going to use to factor. So we want to keep that number kind of handy. And then we're going to square that. So square it. Square it. So take B divided by 2 squared. Now, B divided by 2 squared is always going to be a positive number. This is what we are going to add to both sides. The next step is going to be to factor. Factor the variable side. And remember that this will always be a perfect square. So it will always factor into x, and then we're using that b over 2 number. If b was positive, it will be x plus b over 2 squared. So if b is positive. If b is negative, it will be x minus b over 2 squared. And then this will be equal to some number. So at this point we have a squared thing, so we are going to solve using the square root method. The square root method is the one we just talked about. So we will take the square root of both sides, remember to use plus or minus, and then solve for x. The last method that we used to solve quadratic equations is quadratic formula. Now the quadratic formula always works. So this works for all quadratic equations. One of the drawbacks is that you then have to memorize the quadratic formula, but bear in mind we do have a song for that. There's a couple of cautions. You want to be careful with your signs. Those can be tricky when you're working with positive and negative numbers. And you also want to be careful simplifying your radicals. Here's the steps for solving by the quadratic formula. It has to be in standard form. Standard form for a quadratic equation is ax squared plus bx plus c equals 0. Now, any of these values for a, b, and c could also be 0, and the quadratic formula will still work. Then you're going to use the formula. Let's see, the formula was x equals opposite b plus or minus the square root of b squared minus 4ac divided by 2a. After you've substituted in all of the values for a, b, and c in that formula, you're going to start by simplifying this radical. So work within here, then simplify your radical, and then combine terms as you can, and simplify legally. Don't do anything that's illegal. So remember that you have to, if you're going to simplify something with the denominator, it has to simplify from this term, the coefficient here, and the denominator. We talked a little bit about the discriminant. Remember, the discriminant is b squared minus 4ac. And we discussed what happens if the discriminant is positive, 0, and negative. When the discriminant is positive, you are going to get two distinct real solutions. When the discriminant is 0, you will get one repeated real solution. And when the discriminant is negative, we'll be taking the square root of a negative number, so we're going to get two complex solutions, and those are going to be conjugates.